Hello my dear students, in this lecture we are going to see one previous year gate numerical based on the spring. The first question was asked in gate 2016 in set 1 for 1 mark. The question is based on the spring. Now question is the spring constant of a helical compression spring does not depend on. Now they have given 4 options, right? Here they are asking the spring constant does not depend on. Now my dear students, we know that the spring constant is represented by K, which is also called spring stiffness, and this is given by force divided by deformation. And if I derive this formula in theory lectures, we have proved this formula, which is nothing but G small d power 4 divided by 8 capital D cube into N. This is the formula for spring stiffness. Now my dear students, here G is shear modulus, right? Therefore K depends on G, that is shear modulus. Small d is wire diameter, and therefore again this K depends on the wire diameter also, right? Here capital D is coil diameter, coil diameter. Therefore again K depends on the coil diameter, and N is number of active turns or active coils, right? Therefore again here we can say the K depends on N also, right? Therefore my dear students, here they are asking on which parameter K do not depend. Here K depends on coil diameter, therefore this is wrong. K depends on number of active turns, therefore C is also wrong. K depends on wire diameter also, therefore D is also wrong. Now here in question there is, in formula there is no material strength, therefore option B is correct. Material strength means here ultimate strength SUT, yield strength SYT, then endurance strength AC, then shear strength SSY, right? Shear yield strength SSY. These are the strengths of the material. But here there is no strength in the formula, therefore option B is the correct choice. The next question on the spring was asked in GATE 1994 for 5 marks, right? Now my dear students, the question is to match the pair. Here list 1 with list 2, we have to match the pair. Now generally in old papers they were asking 5 mark question also, but right now there are only 1 mark and 2 mark questions. So if they ask this question, they will ask for 1 or 2 mark. Now here option A, strain rosette. Look at the options. Now my dear students, generally the strain rosette is used to measure the strains, right? Here the purpose of strain rosette is to measure strain, and we have more circle for stress as well as strain. We can draw more circle for stresses as well as for strains. Therefore for A we can say 2, right? Therefore for A the more circle. Then beams, second is beams. Now my dear students, for beam there is a core section, right? There is a core section. Therefore for B we can say option 6, right? For B option 6. Now my dear students, in this spring topic our target is only look at the option D, because in spring only we have seen option number D, right? Other options we have seen either in other part of machine design or in strength of material, such as strain rosette you have seen in strength of material, beams you have seen in strength of material, section modulus again you have seen in strength of material. Section modulus is related with flexural rigidity, right? Therefore for C there will be 4. Section modulus you have seen in strength of material, therefore for C there will be a 4, right? C will stand for 4. Now here wall stress factor is in usually in springs, right? This option D is used in spring, that is coil spring. Therefore for option D we can say, for this option D we can say 3, right? Therefore D stands for 3, right? Then after that the option is fatigue we have seen in machine design. The first topic, design of fatigue, is endurance strength. There will be in fatigue loading there will be endurance limit, right? Therefore for E 5 is correct. Now Summerfield number is only remaining. That Summerfield number we have seen in bearings, right? This number we have seen in bearings, that is sliding contact bearing. And my dear students, in sliding contact bearing there is, we have seen critical speed concept, right? Therefore for this EF we can say option number 1. Therefore for EF option number 1, right? This is the match the pair, right? But here in this topic we have seen only wall stress factor. Wall stress factor is used in coil spring. Thank you dear students. In next lecture we will see one more numerical on this topic.